Hello, this is Science for Cycle 3, Week 15. This week we're going to continue to talk about matter, and we're going to talk a little bit about the concepts of density and buoyancy. So you can start as usual by reading the verse at the top of your lesson plan, and you can start a conversation with your class about how they think Noah's Ark was able to float on the water. Talk about how heavy the ark must have been. It was an enormous boat made of wood, and it had all these animals plus food for the animals and Noah and his whole family on the boat. So it must have been very heavy, and you can ask them how they think that boat was able to float. And so today you can introduce the question. We're going to talk about what determines whether an object is able to float. So in our research, you can review that we've been talking about matter, and review that last week we talked about the fact that matter is anything that takes up space. And we talked about the different states of matter, which are solid, liquid, and gas, and that all of those states of matter take up space. You can review the tiniest building blocks of matter, which are atoms. A couple weeks ago, we talked about oxygen and hydrogen atoms that bond together to form a water molecule. And you can review that the entire world around us is made up of these individual atoms, which are individual elements, which often form bonds with each other to make different substances, and that makes up the entire world that we see around us. And this week we're going to introduce another concept or quality that can describe matter, and that is the density of matter. So density is basically the amount of mass or weight per volume. So it's how much matter is in the space that's given. So things with higher density are going to have more weight per volume or more mass per volume. So this is a little bit tricky concept, especially for younger students. So you can explain it in this way. So if you had a pillow and a bowling ball, if you had the same size of a pillow and a bowling ball, they were the same size, which one would be heavier? Well, the bowling ball would, right? It's much more dense. So if they were both the same size, the bowling ball would be more dense. It has more weight per its size. The same thing is true if you had a big cotton ball and then you had a golf ball that were about the same size. Which one was more dense? The golf ball. The golf ball has more weight per that space that it's taking up, so it's going to be more dense. The cotton ball is going to be less dense. So you can use a few different examples like that. You can talk about items around the room even, what things are the most dense or the least dense that they can find. And then you can talk about the fact that what determines a matter's density is how tightly the molecules in that matter are packed together. So a substance that has a higher density is going to have more tightly packed molecules, and a substance with a lower density is going to have more loosely packed molecules. And there's an image in your lesson plan that kind of demonstrates how the molecules can be more loosely or more tightly packed to give different qualities of density. So we can figure out if an item is going to float or sink in a liquid based on its density. So things that are less dense are going to float to the top. Things that are more dense are going to sink to the bottom. So if we put something that is less dense than water on top of it, then it will float. If we put something that is more dense than water, it's going to sink. There's another force at work, though, that helps us determine whether something will float, and that's the force of buoyancy. So you can talk about the fact that we have gravity, which is always pushing down on us, keeping us down on the ground. But then there's also force pushing up. So there's the water itself is going to have something called buoyancy, which is a force that's actually pushing up against the object that's trying to float. So if an object is kind of wider and displaces more water, then that force of buoyancy pushing up is going to outweigh the force of gravity pushing down, and that item is going to float. So there's a couple different concepts that are at play in determining whether an object is going to float on water. So for our experiments today, our first one, we've got 2 different glasses of water. And so what you're going to do is show your class your 2 glasses of water and 2 raw eggs, and ask them what they think is going to happen if you put the eggs in the water. Are they going to sink or are they going to float? And then for one of the glasses, you are going to add a whole bunch of salt. More salt is better because it will ensure that the experiment works better. So then make sure you spend quite a bit of time mixing up that salt to try to make it dissolve really well. Even if you want to mix it up maybe while you're doing your research, because it helps to just leave it stand for a while. It kind of helps it to give it time to dissolve. Now I've already dissolved some salt in this water, so the experiment should work even if what I just added doesn't mix in completely. And then what you're going to do is at the same time add the eggs, 1 egg each, to the salt water and to the regular water, and have your class observe what happens. So what you can see, hopefully, is that the egg is floating in the salt water, but it sank right to the bottom in the regular water without salt in it. So you can ask your class why they think that's happening and review the concepts that we've been talking about density. So what happened here is that when the salt is added to the water, it gives the water more density. So just plain water is less dense than the egg. So the egg is more dense and it sinks straight to the bottom. But when the salt is mixed in, it kind of fills in the area between the water molecules and causes the water to have more density. And so the egg now is less dense than the water and it floats up to the top. So again, use plenty of salt and give it some time to dissolve, and that experiment will work nicely for you. The next experiment is kind of exploring more with the concept of buoyancy. So you're going to have a tub filled with water. I'm going to use a clear bowl so that you can see it well. And then you're going to give each of your students a little ball of modeling clay. So this is oil-based clay, so it won't absorb water. It's going to repel water. And then just let your class explore with making different shapes out of their clay and seeing whether they float or sink. So again, what they're going to find is that a shape that is more dense and compact, like this ball, is going to sink right to the bottom of the water because it's not displacing a lot of water and has a lot of density. But a shape like this that is flat and rounded is going to displace more water, so that buoyant pressure force that's pushing up against it is going to outweigh the gravity pushing down on it, and it will float. So you can take as much time as you are able to, letting them kind of explore with different shapes. Maybe try putting pockets of air inside their shape, see if that makes any difference. Just let them explore what's going to sink and what's going to float in that water. So again, you can review with both of our experiments that God designed the matter in our world, just like we talked about last week. God designed the matter in our world to follow certain rules and to act in a predictable way so that we can make use of them. Just like Noah made use of the idea of the concepts of gravity and buoyancy to make the ark float, we can make use of the laws that God has given to govern the matter around us. And so you can again review the concepts of density as well as buoyancy and talk through what we saw in our experiments. One more thing, if you have time for it, kind of a fun experiment I've always liked, and probably one you've done with your kids before. You're going to have a glass of water. Sorry. And go ahead and add some food coloring to your water just to make the experiment more interesting. So add a couple drops of food coloring and mix that in to make your water a fun color. And then you're going to add oil. Some of your class probably already knows what's going to happen when you add oil. So I'm going to add some oil, and then you can mix it around for a little bit. And then just let it sit and let your class observe what happens. And what they should observe is that slowly the oil is starting to rise to the top here and the water is staying on the bottom. There's a couple concepts at play here, but the one that we've been talking about is density. So the oil has less density than the water, and so the oil molecules are all wanting to move up. They float on top of the water. The oil and water also repel one another. So oil molecules and water molecules don't like to be next to each other. So they're going to separate. They're not going to dissolve. The oil is not going to dissolve and make itself kind of intersperse with the water. They're going to separate, and the less dense material is going to stay on the top. Now the fun part is to go ahead and take, once you've got it all kind of separated out, mine's still working on it, you can give it a little bit more time if you've got time. Then what you can do is add just a few drops of dish soap and mix it in and see what happens. And what you'll see now is that the molecules aren't separating in the same way. The dish soap is what's called a surfactant, which is a chemical term. And what dish soap allows these molecules to do is allows the water and oil molecules basically to mix, to be able to be next to each other where they didn't used to. They used to repel one another. Well, the dish soap now, acting as a surfactant, allows those to mix. So now we have a nicely blended solution. What's really cool, and you can explain if you've got time, is I love this analogy to demonstrate what Jesus has done for us on the cross. So just like the oil and water repel each other, at one time people could not be near to God because of our sin. We were separated from God, just like that oil and water were separated from each other. They repelled one another, and there was nothing we could do to try to mitigate that separation or try to cross that gap and make our way to God. But Jesus, like a surfactant, like dish soap, came into the world, and because of what he's done, because of his life and his finished work, his death and resurrection on the cross, because of that, he made a way for us once again to be in relationship with God, just like now our water and our oil molecules are able to once again be near each other. So kind of a silly demonstration, but one that I like to give a lot. So again, you can review the concept of density. The surfactant is kind of a separate thing. That is a little bit more complicated chemistry, but still a fun thing to do with your class if you have time. All right, and that is it. Thank you.